Hello, everyone. Appreciate so much for you listen to this class. This is lecture 2. We'll talk about the comparison between GridFree and some primary competitors. I think there are a lot of competitors because the programming concurrency system, distributed system is always a important topic in academia and industry. So during the past maybe at least 30 years, a lot of new programming paradigms and frameworks and other techniques are proposed to resolve the issue of distributed programming. So I make a lot of comparison at least. But in this class, because we have no so much time, so I just focus on the three important ones. I just mentioned Erlang, and Arca, or someone call it Arca, and Go. Go is proposed by Google. Yeah, I just someone call it Golang or Erlang. We just both of them are same actually. All the three ones are the same. So, for example, the basic fundamental programming model for all of the three languages are based on the actor model. So actor model is a fundamental programming component, and so I just when I make this comparison, I will not mention each of them in detail, but I think from my point of view, the three programming paradigm have the same programming foundation, have the same programming methodology. So when I make the comparison, I will not mention them again. But I think when I in the near future, I'm still writing some papers. In the papers, I will make a more detailed survey and comparison. So almost all the existing techniques are compared with GridFree. But because the three ones are mentioned a lot at this time, they're popular. A lot of companies and start to use them to program some existing system, programming some mature system. So I just want to make a comparison between my system with them at first. So in this class, I will do that. So you can see here, there's some comparison I list here. There are three primary difference between GridFree and those Erlang, Go, and Arca. The first difference is a basic programming component. This is the first difference. I think in GridFree there's some. I propose some new programming fundamental components that are different from the existing ones. That is distributed primitive. I mentioned that last time. Distributed primitives. The concurrency model is also different. In GridFree, it can be written in this way. It's asynchronous messaging on the thread level. That's also different from some those popular ones. Distributed patterns. Distributed patterns is also important. If we do not, if the students or if engineer do not care about to create a new programming language, especially for the language is generic to cover all the distributed issues, maybe this one is not so. The distributed pattern issue is not so important. But from my point of view, because I want to create a new programming language to cover all the distributed issues, so distributed patterns is is critical. So I will cover all the three primary difference between my system and some existing ones. Okay, I will talk about them in detail. First, in ArcGo, the actor model is a basic fundamental programming component. This is unique. There are no some others. No other programming model, fundamental models exist. So they just use actor model only. They have an assumption. They believe the actor model can help developers to implement all the distributed system. Do you think so? From my point of view, from my perspective, I don't think so. So here, from actors actually is a concurrency model. Yeah, it's a concurrency model, and but I think this model has some problems. Because I think when we need to design a programming paradigm, the fundamental programming components, the basic programming components, when we need to have a programming component, this one should be used to design. At first, this one should be used to design a distributed system. Because Alka and Go call themselves general purpose ones. So that means we can use the actor model to do anything, right? But do you think so? I don't think so. Actor model is a concurrency and distributed actor model system. This model runs in a way of asynchronous and distributed manner by default. That's different from traditional programming language, for sure. I think this feature is good, the asynchronous and distributed, but I don't think it's a composable enough. Can we use the actor model to design any other system, or can we use the actor model to implement any other APIs or advanced components that are not predefined by those paradigms? This is the one question I asked. I think no any programming language can guarantee all the APIs are proposed by it is already existed. I don't think it is possible. That means a programming paradigm should provide some fundamental programming components. Using these components, we can construct or we can establish some distributed system conveniently. In addition, we can also use those fundamental programming components to design some new APIs or new programming components to deal with some new computing issues, right? It's impossible for a programming paradigm to predefine all the APIs for all of the potential computing environments. That's a common sense, right? For example, in Java have a lot of APIs for us to use. The Java standard edition, right? We can access we can search in the Google Java API, then we can get a specification of all the APIs. However, we can still use this API to design many thousands of or millions of other APIs. You know, there are a lot of Java open source, right? There are a lot of Java open source, thousands of or millions of Java open source. That means we can use Java standardization, using Java APIs to implement any other APIs that are not supported by the initial version of Java, right? So we need to have Java APIs we can use it to design some components so that can process some difficult issues that are not predefined. However, Actor model cannot do that. I don't think Actor model can do that. Actor model is a concurrency. It's from my point of view, is too abstract. If it's too abstract, that means it encapsulate too many techniques that are required to be used to implement implement others. It encapsulates too many details. For example, we cannot see the client. Client is not visible. Server is not visible. Thread is not visible. The concurrency management mechanism not visible. We just see, we can just, when you program an actor, you can see here, this is the actor. This is the code of Akka. When you use Akka, you can regard this code as a server side. It can receive the message PON. After PON is received, it will process the message. It work like a server. The code is very simple, right? Very simple. So it means you can create a server very easily. This server created easily, right? You can do that, and anybody can do that. And this is another. This code is a Golang. You can see the code is also simple, right? It's very simple. That means you can also, this is message. There's some, you can see here, stream bool. There is they call it chain. Chain is a channel. Channel, right? That's a channel. So when you program this language, the channel, we can use the channel to send the messages to the server. The server can use to use the channel to get the message. So, and then they can process the message based on the channel. So although the code is a little bit different between the Akka and the Go, actually they're the same. They look very simple. You can, according to this code, you cannot say how to send the message. Which component is used to send the component? Which component is used at the server? The thread is not visible. You just describe the languages, the business logic in Go routine, but you do not know which thread execute this this code, Go routine. How to manage the all the threads, because there are a lot of thread is important for the concurrency system, right? When a system should be executed in a concurrent way, we need to know how to manage a thread, how to create a thread, how to assign tasks to the thread. How we need to know the status of those threads. However, all the things are invisible. Although the code becomes simple, another problem is caused. That means here, as read here, too many underlying or important techniques are not visible. But all this, I just list some of them here, right? All the important techniques are critical for us to create other more complete and required APIs should be created with these components, right? So if we cannot control these techniques, if all the techniques are invisible to us, that means we cannot program with them, right? That means more complicated system cannot be more complicated computing environments if we cannot use those components. Because those components are invisible to us. Then if a computing environments is difficult, is different from we need to make some changes, we need to deal some complete algorithm. What we can do, we have the active model cannot support these things, right? So we need to control all the details, then we can design a complete distributed system. So that's a problem. This is my code. This is GridFree code. GridFree is still implemented in Java. You can see this is a Java code, right? But at this time, all the APIs and design patterns, or at least most of the fundamental APIs and the design patterns are created. So in the near future, I believe I can create a new programming language based on this code. This code looks a little bit complicated compared with them, right? But here you can see some, although the code is not complete, but you can see the difference. Here you can see there's thread. Here thread is here, and the dispatcher is here. Here dispatcher. Dispatcher is actually a concurrent management mechanism. So you can see the message. This is the server side. This is you can see here message. So the message is processed. This is the server. You can see there is a server dispatcher. So the message is sent from the client to the server, and then it is processed by the server dispatcher. In the later classes, I will talk about how to program with the code. But although the piece of code is very simple, but you can see their total difference, right? This code looks simple, but that means the encapsulation is too many important techniques are encapsulated. That means we cannot use actor or ICA, the actor model to do further programming. We can only use actor to define, to create, or to program some predefined distributed system. I think not great. Yeah, not correct solution. This is the first comparison. This I also list them here, so I do not follow the slides exactly. If you're interested, you can just take a look at them. But I think the major idea, I just talk about the major idea, the major concepts. Okay. At least some here. Maybe we can take a look at the slides. Some important issue I will give a more detailed introduction. Here you can see another concept I need to mention is that when we design, we need to have a fundamental programming component. This component should be computing resources we need, right? Because when we create a new programming system, a new distributed system, that means we need to touch the computing resources directly. If we cannot use the computing resources, we cannot average them, schedule them, and consume them through programming. That means this programming paradigm is not good enough, right? Or at least it's not generic. In some cases, because the computer resource is not be controlled, that means this programming techniques is far from perfect, right? Not flexible. When you use actor model, there's some computing resources here, right? There's some important issue here. If a programming model, if the programming model component, the programming component should be designed good enough, it should be resource. At least first, it should be a resource, computing resource, right? Another one, at least it can be a provider. That means we can is a thread, for example, the resource pool, right? A thread pool, so we can use some computing resources. Maybe there's a consumer, right? So this all the things are related to computing resources. However, actor model is none of them. It all in another word, computing actor model is all of them. Actor model is a resource because when we program actor model, it can provide us some there is some computing resource inside it, encapsulated within it. There may be some data, some thread, and some algorithm, so we can use those stuffs through programming actor model. But actor model is a resource. Actor model is a provider. Actor model is also consumer, because actor model, we can use the actor to send the data from one distributed node to another node. But actor model is omnipotent component. That's not good. I don't think a programming component can do everything. So that means actor model is not flexible enough, right? However, in my system, you can see I list all of them here, all the programming models I proposed. There is here, you can see here, there are 7 ones, different from the actor model. My programming model, component, my programming component contains 7 elements. The first one is server message, the message, right? We need to send, because the distributed system is connected with the messages, so we need to know how to design the message. Another one is a eventer, a synchronous eventer or asynchronous eventer. That eventer is used to send a message. The message can be divided into two types. The first type is notification. The second one is request response. Right? There are two types of message. So the eventer, no matter is asynchronous or synchronous, this one is used to send a notification. So in this case, the server message can be is resources, computing resource, right? The eventer is we can see it regard it as a consumer, right? Reader is used to send request response. Reader is used to in this way, right? And the server says server. Says server is used to receive message. So it's a server. Can be looked as the consumer, also as resource provider, right? Server dispatcher and server dispatcher used to is a scaling up concurrency mechanism. That means when the incoming message is received, the server dispatcher will dispatch it to specific corresponding threads to process them. This is the server dispatcher. Request dispatcher and notification dispatcher. Request dispatcher and the notification dispatcher is a kind of thread pool. This can use, because in the server side we need to support concurrency for sure. So there are a lot of threads we need to manage. So the request dispatcher and the notification dispatcher are responsible to process the incoming to manage all the threads that process the incoming message. Request queue and the notification queue. This queue are actually a thread. They are threads. This is the request dispatcher and the notification dispatcher. They are thread pool. The request queue and the notification queue, these are the threads. But the thread is different from traditional the thread from the Java directly. I upgraded the thread because the Java thread is very difficult to manage. So because we need to process incoming message. This is a message passing system. So I upgrade the Java thread. So although request queue and notification queue are still threads, but they're changed a lot. So so that it's easy for developers to process to program them. It's much better than the native thread from the Java. So maybe you cannot understand why I design those primitives, but in the following classes you can see those APIs will help us to design some, at least at first we can use this primitive to design some simple distributed system, and then more important, we can when a new programming distributed programming computing environment is not predefined, and there are a lot of different complex issues we need to process. In this way, we can still use these primitives to create new APIs, or advanced APIs. The above ones, at least here, the seven types of components, the programming components, I call it primitives. I just mentioned before. But in the near future, in a later time, there are a lot of different company system we need to create it. So we need to create advanced APIs. How to create these advanced APIs? We have to we just use the primitive, because the primitive APIs are easy to be programmed, because I will show that in a later time, and so you can come up with new advanced APIs with them also rapidly, efficiently. Another thing I need to mention, because I need to make the comparison, right? So when you program ICA has the concept of ICA cluster. But in the ICA documents, you cannot see how to create this cluster. How to define the cluster? What the topology of the cluster? What the underlying details of the cluster? We just use this cluster. It's not reasonable, right? Not reasonable, because I mentioned maybe in the previous classes, I said cluster has different types. There are so many different type of cluster because the distributed computing environment is different. Different computing environments have different clusters. So how to define the cluster of the ICA? ICA does not talk about that. Actually, I think this cluster is enterprise level one. But even in the enterprise level, or in the enterprise-based distributed computing environments, there must still some other clusters. So because some enterprise small, some enterprise is large, some enterprise process lightweight message, some enterprises, someone's process high volume data, someone is chatting, for them is streaming, is a video. They're different. So we don't think some large scale, some small scale. So even enterprise have a lot of different types, but ARCA do not mention all the details. If we say some heterogeneous system or socialized system, we need to socialize distributed system. We also need to, if we need to design such a system, then it's more difficult, right? And I think the ICA cluster should not be used in this environment, the socialized distributed computing environment. In ARCA, it does not talk about that, and it also does not talk about how to create this cluster. It's created from using actor model only or not. It does not talk about that. Actually, I believe the ARCA cluster is must create with Java. If a programming paradigm, if this API cluster is a new API or advanced API, but it can only be created with other languages, the third-party language or other language. That means ARCA is not self-contained. It's not flexible. In this way, ARCA is more look like a framework although it calls itself general purpose, but actually I don't think it's a general purpose, but because of this is the one evidence, right? It's not general purpose. It more looks like compared with the distributed some application specific distributed framework, maybe it's more generic or more look like general purpose, but actually because it's a distributed, it's a basic programming components are not defined properly, so I don't think Akka is a generic enough. It's impossible for us to use them to program any distributed system. So yeah, maybe this in this lecture I can finish this talk. We just make the first comparison. In the next time we can talk about some another comparison between the concurrency model. Because concurrency is also important. This is the last slide that we can talk about. Because this idea in this slide that I have to, as I must mention before, DP is a distributed primitive. It tightly with the computing resources. So when you program with DP, that means we can when we program, we can use the distributed computing resources, or we can average all the distributions. We can deploy all the distributed computing resources flexible. So that is a fundamental technique to be a generic distributed paradigm, right? So this is the DP, right? This is the very important idea. But at this time, we have not touched any code. In later classes, I will focus on how to program this DP, how to use this DP to program any other APIs which are not predefined. So in the next class, we'll talk about the issue with the concurrency model, right? Okay, thank you so much for today. But this is all for today. So next class we'll talk about another issue. Okay, thank you so much.